Hello, good afternoon, my dears. Today we're going to review what we have studied regarding forces on motion. Please pay attention because this is an important review of all the topics regarding this very particular unit. Okay, so let's start with mass and weight because this is the very first topic that we studied regarding this unit. Mass and weight in our daily life, we have mass and we have weight. We usually weigh things, okay? So we weigh things using the what? Using the unit of mass, okay? Let's see what we mean by that. What's the difference between mass and weight? This is the important question that we should ask. Mass is the amount of matter in an object or the stuff an object contains. What's mass now? Mass is we have an object, okay? So this object is created out of different matters, okay? So the amount of those matters that create something is its mass, okay? That's why we say the stuff an object contains. So whatever is contained, whatever that object includes, it's what it is, its mass. Okay, for instance, we have a marker that you write on a whiteboard, like a whiteboard marker, or you have a pen in your hand. Maybe that pen is made of aluminum or aluminium or ink, okay, or some plastic as well. So therefore, the mass of the pen that you have is made of aluminium, plastic, and what else? Ink, okay. Although the ink is also created out of several matters being combined together, but still, let's say we have three matters used as the mass of that object that you have in your hand. Or maybe your pen is only created out of plastic and ink. Okay, so this is the mass of that object. And we measure mass in units such as grams and kilograms. Okay, although if in daily life, if I tell you what's your weight, you'll tell me maybe you'll tell me I am uh, 70 kilograms, or I am 60 kilograms, or I am 40 kilograms. So you tell me your weight using what? Using the mass measurement. Okay, so mass and weight are not the same, they are different. Let's see what we mean by weight. Weight is the gravitational attraction or gravitational pull, and it's measured by something else, not kilograms. It's measured by Newton. Okay, so in here, in the picture that you see in front of you, we have mass is not equal to weight. Why? Because mass is the matters that an object contains, while weight, which is for the picture in the right, is the gravitational pull. Okay, it's the gravitational attraction, because we know that gravity attracts objects toward earth. So therefore, Newton is used to measure weight, while kilograms is used to measure mass. To understand what weight is, you need to think about the force of gravity. So we always say gravity. Let's say what we mean by gravity. Gravity is an invisible force that pulls objects towards each other. Okay? By each other means everything will be pulled, or everything will be attracted towards the center of Earth, because we have the bigger amount of gravity when we get on Earth. Earth's gravity is what keeps you on the ground and what makes things fall. So, if you go to moon, if you are on moon, uh, you'll have less weight. Okay, therefore, therefore it means you will have less gravity pulling you towards the ground or towards the flow of moon, let's say. Why? Because when you are on moon, when you are on the moon, there is least gravitational force there, okay, in compared to Earth. And when you go to moon, your weight will change, but your mass will not change. Okay? So objects with more mass have more gravity. Okay? Why? Because they are heavier, because they have inertia, which we are going to study afterwards. Okay? So as you can see in these pictures in front of you, that apple is coming downward towards the earth, while this man is on the moon. In the picture of your right side, this man is on the moon and flying. Why? Because there is a less gravitational force to attract him towards the earth. Okay, so this can be a comparison between mass and weight. Mass of an object does not change when the location of the object changes. So let's get a human being. A human being is made out of skin, skeleton, cells, organs, anything, blood, so, or let's say systems, anything that's within a human being. So that human being, when that human being goes to be on moon, nothing changed about that human being. Still, he is created out of skin, skeleton, organs, cells, whatever that human being contains on Earth. Still, he or she contains the same thing. But the weight will change. Why? Because the location has changed, because you have traveled from Earth to Moon. Why you have traveled that? To see whether your weight will change or not. But yes, exactly, it changed. Why it changed? Because on the Moon we have less gravitational force, because gravity will no longer exist when you reach Moon. That's why your weight will change a lot of numbers, let's say, in compare to when you were on Earth. Okay, so the gravity changed my way. Change. That's why your weight will change when you go on a moon. The force of gravity that works on the mass is the weight. Okay, which means the weight will change, but the mass will never change. Okay, so we have two instruments, two tools, let's say, that we use in order to measure mass and measure weight as well. In the case of mass, we use scale in order to know um, how many grams or how many kilograms an object is, which we use daily or which the shops use daily. We also have force meter, or it's called by Newton meter, in order to weigh weight. Okay, so it's measured by Newton and not kilograms. Okay, so force meter is used to weigh weight, while scale is used to weigh mass. Okay, so now we reach another topic, which is regarding forces. Okay, so forces, in this life we have plenty different types of forces. We have variety of forces, but what we are going to concentrate on during the explanation of forces and motions are the ones that we need for this very particular year. Okay, so force of push and pull. We will talk about friction, and we already know what's gravity. Therefore, we will be uh, going through them in detail. Okay, so let's see what we mean by the forces. What are forces? A force is a push or pull upon an object. We apply forces whenever we are pushing or pulling an object. So in here, in the very downside of the paper, you can see that there is a man pushing an object, and it's written push, and there's someone else who's pulling an object. Maybe it's a flag, let's say, or it's a box, let's say, and it's called by pulling. And in order to do these activities, in order to push and pull, you'll need force, you'll need energy. Okay, so let's see why we call force energy. We will see that in the upcoming lessons. Push and pull are the two most used words when it comes to the notion of forces, or when it comes to the explanation of the forces. Let's see some facts about the forces. Let's see what the facts are. Forces act in pair, which means there's not only one force at all. When there's a force, there must be another force at the same time. Each force acts in the opposite direction of the other force. So when you are putting a force, when you are pushing an object, there's another force that's pulling that object. Do you know that? This is called by facts about forces. As you can see in the picture of your right side, we have forces act in pairs. Let's see what happens. We have a man driving a car. Okay, that car has a force when it goes. Okay, it has a force, which that force has a name, but still we haven't studied that. Therefore, I'm not going to tell you. So force of car is going towards a wall. Okay, that wall standing over there has a force as well, and it's called by force of the wall. If that car hits the wall with a force, and that wall tries to stop the car with a force, there will be what? There will be the car accident that has happened because of the wall and the car. Okay, because of these two forces. Therefore, the car will be destroyed and the wall will also be destroyed at the same time. Why? Because these are two forces working in different directions, working in opposite sides, working in pairs. If you have a book on a table, there's a force that is pulling the book towards Earth. That force is force of gravity. But there is another force that tries to make the book stay on the table. That force is of the table, and we call that as reaction force. Reaction to what? Reaction towards gravity. Okay? Therefore, we have two different forces, and they are working in different directions. We have the book on the table. We said that gravity will be pulling the book downwards towards Earth, and we've got the table that's pushing up the book upward so that it doesn't fall. When you try to move the book to the right side, there's a force that doesn't let you to do that very easily, and that force is called by force of friction. Okay, between what? Between the book and the table. Okay, so when you move the book to the right side or rightward, what happens? There's a force that tries to get the book back to the leftward. That's why forces act in all directions. They have the four directions, and they actually work in those different directions in order to actually for our life to be easier. We need to have forces. Okay, why? Because if you don't have forces, you cannot drive a car, you cannot not walk, you cannot stand up actually. Okay, we have something else that's called by force diagram. Force diagram is a drawing that shows the direction and the size of forces acting on an object. Okay, so it shows the direction and it also shows the size. As you can see this diagram below, we have the main four directions of the forces, and we also have their sizes as well, their measurements. We have 100 Newton from the left, we have another 100 for the upward side, we have another 100 for the downward side, we also have a 15 Newton in the rightward side of the diagram. Okay, so it tells us how is the size of the force and to which direction it goes. So this is force diagram. Very easy. After that, we get to another topic regarding forces, which is called by balanced and unbalanced forces. If the forces acting on an object are the same size, the forces are balanced. As you can see in the first picture, we have rope pulling in here, three people pulling from the right side and three others pulling from the left side, each with the same weight. Okay, the same weight is what is 300 Newton for each side. Okay, therefore the rope will be balanced and neither sides can get the rope. Why? Because the force is a balanced force, therefore they will continue on pulling. But if you look at the picture that's in the below that picture, you can see that the left side has more power, which is the weight of 400 Newton, while the right side has the 300 Newton weight. Okay, so therefore, which side is stronger? The left side is stronger. And the balance of force is unbalanced. It's not a balanced force because one side is more than the other side. Therefore, the rope will be pulled further to the left side and not the right side. Because of what? Because of having more weight, because of having more force from the left side towards themselves. Okay, therefore this force can be what? Can be the unbalanced type of force. So we have another topic which is called by forces and energy, but first let's see what happens in the case of effects of a force, like what are the effects of a force. As you can see in these four pictures, we have four people, four men, working on what? On different types of objects. A man uses a force to move a stationary lawnmower, as you can see, and we have a cyclist uses a bigger force to pedal his bicycle and increase its speed. So a force is needed for that purpose, like a force is needed in order to ride a bicycle. Also, we have a footballer uses a force to change the direction of motion of a ball. So forces are needed in order to change direction, forces are needed to move an object, and forces are needed to increase speed. Also, a baker uses a force on his dough to shape it into a curry puff. So a force is needed to create shapes at the same time. Okay, so forces are used for movement, for increasing speed, for changing directions, and for changing shapes or making shapes. Okay, so let's see what we mean by forces and energy. First of all, there's a word or a new notion that I would like you to have a knowledge about, which we call as inertia. Inertia is the tendency of an object to stay at rest or preserve its state of motion. In here, for instance, I am sitting on a chair, okay? So I am stable here. I have an inertia. I want to stay here. Even if somebody comes, pulls me or pushes me, still I want to stay here. So this is my tendency to stay here because I want to be here. So this is my inertia. I cannot move very easily. Okay, let's see how inertia can be used. A force is needed to make objects move or to stop them moving. Of course, if you don't put a force on an object, that object will not actually provide any movement or any change of direction. When we exert a force on an object to make it move, we give the object energy. Okay, so as you can see in these two pictures, this boy above is forcing the car to move forward. Okay, so in this case, what he's doing, he's giving energy to the car in order to move. While in the second picture, the car is going to stop because of another force. Okay, why? Because you have already given energy to the car, and enough energy is given to the car to move. Okay, but it was not like more than the energy, more than the force that a wall has. Therefore, when it hits the wall, it's going to stop. Let's see, what do we call the energy or the amount of energy that we give to an object. The amount of energy transferred to an object to make it move is called by work. So the amount of work done depends on how far the force makes the object move. If you give that ball, if that boy gives the ball enough energy, okay, to get in like directly into the goal from the other side of the stadium, what do we think? We will think that there has been so many energy transferred to the ball, therefore there is too much work done. Okay, the further the object moves, the more work is done as more energy is transferred. So as long as you provide more energy, you give more energy to an object, we will say that you have given more work to the object. Okay, so the amount of work depends on the energy that you give to the object. We call the force applied to an object work. So the force that you give, the energy that you give to an object, we call it as work. When force is applied to an object, it results in the movement of the object, and when this happens, the work is said to be done. So there must be a movement, there must be a change of direction, there must be a force or an energy given to an object. Okay, in this case, and the object should move, should be displaced. In this case, the work is said to be done. There is a work that has been done by you. Therefore, we have different types of works. We have positive work and we have negative work, because sometimes when you put force, when you give energy to an object, that object doesn't move. So it's not a positive work. This is rather negative. Let's see what we mean by positive work. A positive work follows when the force has a component parallel to the displacement, which means there is change of direction, there is change of movement, there is displacement happened to an object. We call this as positive work. But if you push a wall and the wall doesn't move, this is what? There is no displacement, there is no movement. Therefore, it is what? It's a zero work done because no movement happened. How about negative? Negative work follows when the force has component opposite or against the displacement. So, in the case of rope pulling, both sides they pull an object, which is the rope. Okay, therefore you have what? You have a, an opposite side of force. Okay, against what? Against the pulling of the rope. And if the force is what? Is equivalent, is the same as the force that you are putting on the rope to pull, it's a negative work. Okay, why? Because a force is what? Is removing or dissipates energy from you. Okay, which means you are spending energy but still the work is negative. Okay, because there is a force that attracts the rope towards itself. Okay, therefore we have what? We have constant velocity. In the case of that man pulling the crate in the left side, the crate doesn't move, therefore there is no work done. Also, in the case of constant velocity, that man is holding a box in his hand. There is a constant movement of the man, but not of the object. Because of what? When an object is carried at constant velocity is the rate of change of its position. So no position is changed by a force which acts at right angles to the motion. No work is done on the object. Because of what? Because constantly the man is having the box in his hand even though he himself is moving, but he does not move the object at all. Therefore, it's called by constant velocity. In here, this ball requires energy to get into the goal. It requires what? It requires a force. If there is no force to make the ball to move, if there is no force to be applied on the ball, we will say that there is no work done. From the left side, we have this guy. It's the first day of gym. He goes to the gym and tries to handle a very huge amount of kilograms, but he could not do that. Even he tries so hard, but it doesn't make any movement. Therefore, it's a zero work done. Okay. So also we also explained how how we can apply forces to an object and how we give energy to objects and what are the different types of works that we can have when we are putting or applying force on objects. Now we're going to start with another topic which is called by friction. Okay, so in order to know what friction is, you must have understood the topics that we explained previously. Okay, so let's start with friction. Let's see what friction is first. Friction is a force which tries to stop things sliding one another. So if you rub your hands against each other, what will you expect? You'll expect warmth. You'll expect your hands to get warmer. Okay? Therefore, the reason behind this is because of friction. Okay? So when two objects rub against each other, friction happens. Okay? As you can see, friction only acts on moving objects and it cannot make objects move at all. So you cannot give friction to an object. You only can make movements in order for friction to happen. Friction changes the energy of moving objects into heat energy as the object slows down. So when there is an object that friction happened to it against another object, what happens? The energy of moving has been changed to what? To heat energy. Okay, because as you can see, this man over here is trying to cut a piece of wood by using a saw. So after that, when he finishes, although we know that the cutting will happen because of friction of the metal between the metal and the wood. When it finishes, you can touch the wood and you will feel the warmth, or you can touch the saw and you will feel the warmth. This lady over here is rubbing her hands against each other, and what happens? She will get warmth, like the hands will get warm after she stops. Okay, so let's see how friction is useful for our life. You could not walk without friction between your shoes and the ground. Friction holds your shoe to the ground, allowing you to walk. Think, if you are like you're wearing your shoes in a day like this, for instance, you're going into an alley because the streets have been cleaned. You'll see that there are, let's say, pieces of snow or pieces of slippery, uh, let's say, grounds on the floor. So when you go into the alley, you'll definitely see that. If you put your shoe on it, you'll slip. Okay, because of what? Because of friction. Why friction? Because on the slippery floors, on the wet, icy, or slippery floors, there will be least friction. If you have more friction, you're more likely to walk safely. But if you have less friction, walking will be difficult for you. Okay? If you have more friction, you can handle your pencil. If you have more friction, you can drive your car easily. You can brake, you can stop the car because of friction, because of having a more amount of friction. But if it's least amount, if there is less amount of friction, then you cannot handle your pencil. You cannot handle a car that you're going to drive. You cannot handle your bicycle because there is less friction. Okay? So therefore, it's very important for those who are driving cars, who they have bicycles. They should change their brake. They check their brakes, let's say, and because if it gets very slippery, it will not stop the car. Therefore, it needs to be changed in order for the friction to happen and the car or the bicycle to be stopped. Okay, so apart from all the usefulness or let's say important points for our daily life about friction, it can also cause problems. Okay, friction makes things to wear away, okay, to be wasted, let's say. Especially it happens in the case of machines or engines. If there is no friction, those engines cannot work. But also friction will make the parts to wear away, to be wasted. So in order to protect that, now the companies are producing oil. Okay, so scientists found that oil will help the what the life of the machines, the life of the engines to stay or to be longer. Okay, because oil will create a layer on the parts or on the particles on the different types of engine parts in order when the friction happens the the layer to protect the parts of the engine. Okay, so that layer of oil will protect the parts of the engine. Okay, so it is not the parts that are making the friction, but it's the layer of oil that's on the parts, and it protects the parts of the engine. Okay, therefore lubrication is important for whoever is driving a car. They must change their oil constantly. Okay, they must take care of their cars or their engine parts. Okay, in order for the car engines to live longer, they need to put oil into the engines, and they must change it constantly in order for the oil not to what to get expired. After all these, there are four major points that will affect friction. So we said that the more friction, the better walking, the better driving. The less or least friction, the harder to walk or the harder to drive. Let's see what are the things, what are the qualities that can affect friction. First of all is material. The second one is weight of an object. And we have surface area, we also have liquids. Some materials will create less friction due to their surfaces. Things that are heavy will be subject to more friction than things that are light. If the area of the two objects rubbing together is large, it will create more friction. The addition of a liquid can reduce friction by making the surface slippery. Dry surfaces tend to have more friction. So oil is a liquid, therefore it's used in order to make the surface of the car engine parts more slippery. After that we get to air resistance and drag. Let's see what we mean by air resistance and drag. Have you ever held your hand out of a car window? If yes, what did you feel? If not, do it. Let's see what you feel. Every time an object moves, it will experience air resistance. This is a pushing force. You can feel it push your hair back and make your clothes ripple as you run or ride your bike. So, when you ride a bike or when you're moving, there's a windy day, what happens? Your hair will move, okay? Or your clothes will also be rippled or will be moved, okay? Because of what? Because of air. Air is a mixture of gases. The particles of gas push against things which are moving and create a force. This force is called by air resistance. Another name for it is drag. Air resistance pushes against a moving object, such as a car, and slows it down. The larger the surface area of the moving object, the more air resistance there is, which means moving objects can have what? Can actually have something to make them slower, which we call as air resistance. In the case of cars, when cars have less surface area or smaller surface area, they can move faster. But if they have larger surface area, they will move slower. Therefore, the sports car are different from the buses. The sports car are different from other different types of cars. If you have noticed, the sports car are smaller, they are more flat, they can, let's say, go so fast because they don't have very large surface area. They don't look very big. They usually look small. Okay, so therefore there will be less air resistance for the sports car, while there will be more resistance for a bus. So therefore air resistance also pushes against falling objects and slows them down. So moving objects, they face air resistance. How about falling objects? They also face air resistance. But how? A parachute uses air resistance to work because it will be full, it will be filled with what? With air, and it has a large surface area. Therefore, it's very light in weight and has a very big surface area. It catches lots of air in it as it falls down, so it creates a lot of air resistance drag. Okay, so the air is stabilizing the parachute while it's in the air. Okay, so the air resistance causes the parachute to fully open and become as big as possible. And when the parachute becomes as big as possible, what happens? It stays, it stabilizes, it comes down slowly because there is air resistance. Air resistance is the force that opposes the motion of objects through air. The amount of air resistance acting on an object depends on the size, shape, and the speed of the object. So the size and shape of the object will definitely make the object to go slower or to go faster. Small objects tend to come down faster. Okay, why? Because they have a smaller shape. Okay, but when there is a size, when there's a car that's very heavy, okay, it comes down faster or slower. Right, the answer for that in the comment section, please, or I will make it an assignment. But please write it down in the comment section, even if you feel that your friend is going to know the answer from you. Please write it down. So size, shape, and speed of the object will also indicate the amount of air resistance. Okay, so air resistance doesn't work, let's say, more on the smaller objects, but it works more on the objects with larger surface area. Okay, I've also sent you a worksheet regarding the creation of the parachute or testing the parachute. Please, for those who haven't done it yet, please do it. And I'll also be sending a quiz to you regarding this unit. This was just a review for you to understand more about what we have studied during this week. Thank you very much for attending the class. Wish you all have a very good day. Bye bye.